Hello, my name is Caleb Scott, and today we will dive into a mathematical formula known as the voltage divider rule, or VDR for short. The important theories related to VDR are Ohm's law and Kirchhoff's voltage rule. To explain these, we can use an analogy with water flowing through pipes. In this analogy, voltage is like a water pump, resistors are thinner sections of pipe, and current is how fast the water flows. When the pump pushes water through the pipes, it will flow at a certain rate depending on the strength of the pump. If the water must be pushed through thin sections of pipe, it will take more time to flow through the loop. This roughly explains how Ohm's law works. The total current flow depends on the pushing force, the voltage, and the inhibiting force, the total resistance. In other words, I is V over R. For Kirchhoff's voltage law, we can think of the water as having energy when it's pushed through the pump. By the time it returns to the pump, it shouldn't have any energy, otherwise it will gain greater pushing force than the last loop, increasing indefinitely. This is the principle of KVL, that the sum of all voltage sources and voltage drops in a closed loop must equal zero. Combining these ideas, we can deduce that the voltage must drop across resistors to provide this net zero voltage. Using Ohm's law, we can find the total current in the circuit. Then, again using Ohm's law and KVL, we can say that the voltage drop across a resistor is the total current, E over the sum of R, multiplied by the resistor we want to find. This is the basic principle behind the voltage division rule. Now, moving on to a practical example. If we take the circuit to the right, we first need to calculate the overall current, E over the sum of R. We get 10 over 6, or approximately 1.7 amps. Then, using the VDR formula, we multiply this value for the overall current by the resistors we wish to find. Starting with the 1 ohm resistor, we get 1 multiplied by 1.7, or 1.7 volts dropped. For the second resistor, we get 2 multiplied by 1.7, giving 3.4 volts dropped. Finally, for the third resistor, we multiply 3 by 1.7 to get 5.1 volts dropped. Now, to verify this answer, we sum all of the voltage drops together, 1.7 plus 3.4 plus 5.1, to get a source voltage of approximately 10.2 volts. This difference is explained by the rounding made earlier, as 10 over 6 is 1.6 repeater, not 1.7. That is it for today. Once again, this is Caleb Scott, and that was a summary of the voltage divider rule.